data in a table, okay, we always want to find out the totals, okay? The totals of each eventually will help us, okay, will help us if we need them, okay? So you need to find the total of full-time, part-time, unemployed, okay? Then the total of 0 to 17, 18 to 25, 26 to 34, 35 to 49, okay? So what were the totals for full-time? What was the total? Okay, we're going to do that today. Josh, the total for full-time. Lizzie. Okay, do you guys have your calculators? Gavin. Beautiful. You? 1581. Okay. The total for part-time, Mustafa. Okay, Finn. Abigail. 775. Unemployed. The total for unemployed, Bianca. Okay, Lindsay. Emily. 823. Okay, now our totals for 0 to 17, Brian. 0 to 17. 559. Okay, 18 to 25. Well, 536. Okay, 26 to 34, Tori. 442. Good. Okay, 35 to 49, Sam. 864. Good. 50 plus, Campbell. 778. And in total, how many people did we have? Jackson. Okay. Laurel. A little more than that. Okay. We have 3,179. Okay. 3,179 should be the same for both. Okay. So now it's important. You may not think it at the time that why do I have to figure out the totals? It could have been any question given to you. Why not have the totals already done? Okay. Anytime you're working with a data table like this, two-way table, you want to have your totals completed. Right? So for A, if a person in this town selected at random, find the probability that the individual is employed part-time, given he or she is between ages 35 to 49. Josh? Perfect. So whatever comes out after given between ages 35 and 49 is your denominator. Out of that total, how many of them are part-time, which was 179? Okay. Now if we look at B, what is the probability that a randomly selected individual is unemployed given he or she is over 50? John? Perfect. Good. Okay. Now we look at C. Person from the town is randomly selected. What is the probability that the individual is employed full-time given he or she is between 18 to 49 years old? Sam? Good. Okay, which reduces to, so in this particular problem, okay, it's 18 to 49 years old. So we had to add together the totals of 536, 442, and 864 for your denominator. Then those that are employed full-time, 185, 348, and 581 would be your numerator. Okay? So your full-time of these three categories over the totals. Okay? Then for D, a person from the town is randomly selected. What is the probability the individual is employed part-time given he or she is at least 35 years old? Andrew? Perfect. 341, 16, 42. Okay? Any questions? Okay. Did you guys, let me just double check because I know the numbering was a little out of control. Okay. So we're going to do the next two. We have marbles and then we have cards. Okay? So, consider a bag with marbles, 3 blue, 2 red, and 5 green. So how many in total do we have? 10. So we have 10 in total. Okay? Now this is notation for dependent, okay, events. Now keep in mind there's 3 marbles being drawn, excuse me, being drawn in a particular sequence, okay? For every marble that is drawn, you're not replacing it, okay? Key word, key phrase there. So, probability of the second draw is blue, given the first draw is red. So you have already selected a red marble. What is the probability of the second one being blue? Rory? 1/3. It's 3/9. Because you lose one because of red, and there's 3 blue. It's 1/3. Okay? Number 2, probability the second draw is blue, given the first draw is blue. Abigail? 2/9. Excellent. Okay? And the third one, probability the third one's blue, given you have already drawn a red and a blue. Julia? 1/4. It's 2/8, which is 1/4. Okay, then the last one is first draw blue given the first draw red. Josh? Perfect. Excellent. Good explanation too. Good job. Okay. Any questions on that one? Okay. Now, favorite. Some of you not so much, but cards. Okay. Playing cards is where a lot of probability takes place. Okay. So just a refresher, there's 52 cards. Okay. 26 are red, 26 are black. Okay. There are 12 face cards, which consist of king, queen, and jack. Okay. 12 face cards, king, queen, and jack. Okay. There are 4 suits, spades, clubs, diamonds, and hearts. There's 13 cards in each suit. Okay. 13 cards in each suit. Okay. Some basic facts of cards. So now, probability of drawing a queen given you're taking it out of face cards. So how many face cards do we have? 12. Out of those 12, how many of them are queen? 4. This is 2, 1/3. Okay? So this notation actually sets up what you're looking for. Okay? Probability of drawing an ace. Okay, so these are your aces out of lettered cards. So how many lettered cards are there? 16. King, queen, jack, and ace are all lettered cards. Out of those lettered cards, how many of them are aces? 4. 4. Okay? Probability of a heart with a number, given it's a red card. So how many red cards are there? 26. Out of those 26, how many of them are hearts with numbers? Sam? 9. Good. So 9 6. Okay? Then the next one. Probability of card with a letter, given that of kings. How many kings do we have? 4. Out of those 4, how many of them are lettered? 4. All of them. So 4 out of 4, which is 1. Okay? Then the next one. Probability of a number less than 6, given it's a face card. So how many face cards do we have? 12. Out of those 12, how many of them have a number less than 6? 0. Good. All right. Probability of an odd number, given it's a numbered card. So how many numbered cards? Sam? 36. Out of those 36, how many of them are odd? Go. 16. Good. So 16 out of 36 hornets. Okay. Does everyone see how this works? Like, are we still a little confused, or are we okay? Okay. This notation actually sets up your probabilities. Okay. This one, whatever comes second, is what your denominator would be. Just like what we saw in some of those examples previously in terms of employment. Okay. Were there any questions on any of the practice you guys went through? God bless you. I know the numbers were a little wonky, and I apologize. Okay. We're actually going to still be in the practice. I'm going to go to this one. Okay. It's at the bottom of one of the pages. I think on your packet it's labeled number 4. Right? Okay. So this is a different way of filling out a two-way table by given percentages. Okay. So 40% of students are juniors. So we have a total of 120 students that are being surveyed, right? How many of them are juniors? Steve? 48. How'd you get it? Okay. We could do that. Perfect. Or we have 0.4 times 120, which is exactly, you'll get the same answer. There are 48 juniors. Okay. Yep. It'll be both. Okay. Then we have 25% of juniors studies bio. So what would I do here? Rory? Good. Since they're only speaking about juniors, it's 0.25 times 48. Okay. So how many juniors study bio? Go ahead. 12. Good. Okay. Then we have 35% of students are seniors who study physics. So what would we do here? Emily? That would just give you the total of seniors in general. Okay? this is looking at, and I like your thinking and thinking out loud because that's what a lot of people would do, okay? Here is 35% of students. So it's looking at the whole big picture, okay? So we would take 0.35 times 120, okay? So how many students are seniors who study physics? Yep, 42. And where would that go on this chart? Go ahead. Where? And what was it? 42. Good. Okay? 45% of students study physics. And same thing, you're looking at students, so 0.45 times 120. And how many students study physics? John? 54, good. Okay? And 30% of students study chemistry. 10.3. How many students study chem? Laurel? 36. Okay. So based on the percentages given, we were able to fill out part of the chart. Okay. So your task right now is to complete the chart if you haven't done so already and answer the questions that follow. Okay. I'll give you about 5 minutes or so to finish the chart and answer the questions. All right, you guys, let's go through these. Okay. The completed two-way table is on the screen. Okay. So for B, what is the probability that a student studies bio? So you're looking at all the students. Okay, so out of 120, it was 30 out of 120, which reduces to 1/4. Okay, which is correct. Then we look at what is the probability that a student, so right there, probability that a student chosen is out of 120. So out of 120, how many of them are seniors and does not study biology? Sam? 9 out of 20. Before that, it was 54 out of 120. Okay. Then for D, what is the probability that a student, so again, you're looking at the total of 120. That's going to be your denominator. Is a junior and studies chem. So you look at the intersection where they're both occurring. Okay. So it's 24 out of 120, which is 1/5, which is correct on the board. Okay. Then E, what is the probability that a student is not a junior? Okay, so it's the seniors. 72 out of 120, which is 3/5. That is correct. Okay. Then for F, what is the probability that a student does not study biology? So again, your denominator is 120. Does not study bio is chem and physics, which is 90 out of 120, which is 3/4. Okay. What is the probability that a student chosen at random? So again, denominator 120. Studies chem or physics, 90 out of 120. Okay, so pretty similar to the one above, right? The previous one. So we should get 3/4. And anytime you guys have these, always reduce. Okay? Now for H is where you should notice a difference. Okay? What is the probability that a randomly chosen junior? So instead of 120, what is our denominator going to be? 48. Out of those 48, how many of them study physics? 12. 12 out of 48 gives you the 1/4 that you see on the board. Then what is the probability of randomly chosen chem student? So now we're looking at chemistry, which is 36. How many of them are seniors? 12 out of 36, which is 1/3. Okay? So, how many of you got all of those correct? A few. All right. Just understanding when the denominator is as a whole or only as a piece. Okay, it all comes down to wording. All right, so today we're adding on to our probability knowledge in terms of symbols. Okay, so have your notes out and turn to 3.3. You actually probably saw a snapshot of it on your answer key. You're probably like, what the heck is that, Miss Spetta? We're going to get to it. You're going to notice what it looks like in a second. Okay, so in your notes where it says 3.3 notes, set theory. Okay. All right, so a set is a collection of distinct objects, so no repeats, okay? It's often denoted by a capital letter. So anytime we're talking about sets, you're going to have a capital letter. Some of them, some examples that you would see, for example, set A, 1, 4, 6, 10, and 12 are included in that set. Set B, an example, all ninth graders. Set C, turtles, penguins, mice, and bears. Okay? So each of those things in a set is called an element. Okay? An element is what elements are what make up a set. Okay? To denote if an element is contained in a set, we use the symbol like E here. Looks like an E. Okay? If it's not in a set, we put a line through it. Okay? So for example, 4 is in set A, but 5 is not. Okay? All ninth graders are in set B, but what would be an example of not in set B? Charlotte? 10th graders. 10th graders are not in set B. Turtles are listed in set C, but dolphins are not. Okay? So that notation with that little E means it's in that set. All right? So now we get to a Venn diagram. All right? What are the elements in set A? So what makes up set A? What numbers? Well, excellent. 1, 2, and 3. It's this whole circle of A. What elements are in set B? John? Excellent. Okay, and again, those squiggly brackets are back. Okay, that represent a set. Okay, we saw that in set notation. That makes sense. What elements do set A and set B have in common? 3. Okay. What elements does set A have that set B does not? Mustafa? 1 and 2. Okay. All right. So the next problem that you'll see, you guys are going to try, where you have animals and things that fly are the two events. Okay? So you're going to answer these 3 questions. Go ahead. How many elements are in the set of things that fly? Brian? 7. Good. This whole circle. All right. What elements are animals that cannot fly? Sam? Good. Sure. Good. Write the set of animals that can fly. Rory? Good. Bat. bird, bee, and butterfly. So that's the way I'm saying for both. Okay? When we get back from lunch, okay, we're going to get through the notation, which you probably saw on the key of some sort. You're like, what's going on with that? We're, we're going to talk about the notation. The notation is important. However, it can be confusing when it's all together. All right? We will pick up there when you guys get back from lunch. Have a great lunch. Is the universal set are containing all the objects or elements in a set. So in all sets. So for example, if we had two events here, let's just say you guys would all be part of the universal set, okay? And I would split you up into, like, say, two groups, okay? But you're all a part of the universal set, all right? It's all the possible containing all the elements or objects, all right? The null or the empty set means there are no elements, okay? There's nothing in them, all right? So some terms and symbols, which you probably saw in the key, the intersection, okay, with this upside down U is and, where they're both occurring, okay? So the intersection of both events, okay, what they have in common, that's the and. Now, anytime you see the U in between two sets, it's called the union. Now, be careful with this because the key word for union is or. However, it's either A or B or both. So it also includes that middle piece, okay? Please remember that. Anytime you see union, the U, or it says or, it's including the intersection as well, okay? The next one is the complement, meaning with that little C or line over it, meaning it does not belong in set A. So we totally do not shade in set A and whatever's in B and the outside. So when it says not in A, it is completely not shaded in. It's everything outside it. Okay? So those are the three terms and symbols to remember. Okay? We are going to write a few things in words. All right? Then do some examples from here. So, if we see the upside down U, what does that stand for? John? And. So this is in set A and set B and set C. Okay? In set A and set B and set C. Okay? What does that little C stand for? Yep. Right. So this means not in set B. Okay? Not in set B. All right? So then when we have the U, means union. So if we were to write it in words, this is in set B or set C or set D or all three. Okay? So if I was to do a Venn diagram so you kind of get an idea of what this looks like. Okay, this is a three-circle Venn diagram because B, C, and D are all different sets. If it's in set B or set C or set D or all three, this is what it would look like. Okay, all three circles will be colored in. So for D, this means not in A or B or both. So it would just be the outside. Okay. All right, so we're going to get to an example. All right. We have 3 sets here. We have set F is Haley and Taylor. Set G, Mom, Dad, Taylor. Set E, Mom, Haley, Muddy. And the universal set, so everybody that would be included is Mom, Dad, Haley, Taylor, Muddy. Okay? So that's all the names in the universal set. Okay? So we want to know what is in F and G. So the intersection, what do F and G have in common? Josh? Taylor. Good. Okay. Then the next one is F or G or both. So who is in F or G or both? Josh? Perfect. Good. Mom, Dad, Haley, and Taylor. Okay. Are we all okay? All right. Then for C, this is not in E. So, who is not in E? Brian? Good. Dad and Taylor. Excellent. Good. All right. Now for D, this is F and G and E. So basically, is there anyone in all 3? Rory? Who? Careful. In all 3, F, G, and E. Andrew? Nobody. Haley's not in the G category. Okay. So, no one. So this would be the empty set. Okay. All right. So the next 2 combine notations. Okay. So this means who is not in F and G. So in other words, who is not in that intersection. Okay, between F and G. Yellow. Muddy is 1. Who else? Campbell? Good. So basically, F and G we already found out was here, right? So it's everybody else besides Taylor. So it's Mom, Dad, Haley, and Muddy. Okay? Do you guys see that? All right. And the last one. F. What is not in F, but it is in E. It is not in F, but it's in E. Sam? Mom? Anybody else? And Muddy. Good. Okay. So, there might be some of you that prefer to do this visually. You can. Okay? You could do this visually by creating a Venn diagram. All right? Which we're going to see next. Let's turn the page. All right. So, if set A, we're going to label A and B. If set A is January, February, March, April, September, December, set B is April, May, September, November, and the universal set, so that whole Venn diagram has to include all 12 months. So first and foremost, which months are both in A and B? Mustafa? Anything else? April. So April and September are in the middle. April and September in the middle because they're both in each other's set. Okay. Which months are only in A? Brian? Good. Okay. Which months are only in B? Well, May and November. Okay. Are we missing any months? Rory? Good. So June, July, August, and October. So those 4 months are not in any of the sets, so they go on the outside. Okay? So again, notation. Which months are in A and B? Phoebe? April and September. Okay, A and B. Okay, which months are not in A and B? Brian? Anything else? This means, remember, A and B, so that's the intersection. What is not in the intersection? Perfect. Good. So we have January, February, March, December, May, November, June, July, August, and October. Some people have asked in other classes, do we have to write them in order? Is there a shortcut? No to both, okay? If you want to, you could write them in order. However, that's the least of my worries. If you know what this means and list them out, you're good. You are golden. If you go the extra mile by writing them in order, if they're numbers or in this case months, go ahead, but not necessary. Okay? Some people have asked, is there a shortcut? No, you have to list. You have to list them out. That's what set notation is. Okay? Now for C, A or B, or both. A or B or both. Brian. Excellent. Good. Good. Okay. So again, this is or. So A or B or both. So I would shade both of those circles. Okay. What is not in A and B? It's everything excluding that middle. Okay. If it's A and B, it would be April and September. Okay. How about if I asked for this? A with that little C. Yeah. Anything that is not in A. So what would that be? John? Perfect. Okay. So you guys are going to try one on your own. All right. Number 3. You have if set F was 2, 5, 7, 8, 9, 12, set G, -3, 0, 5, 8, 12, 17, and the universal set includes integers from -3 to 18. Okay? So, remember that you want to list them out. You can't say -3 to 5, let's just say. Okay? So go ahead and try number 3. I will fill out the Venn diagram in a few minutes. but also answer these questions. Okay? If you do have your course selections sheet with you and it is filled out with the math course that you want to take, please let me know. All right, so for your Venn diagram, okay, we should have had this filled out. All right. The only three numbers that were in the intersection, 5, 8, and 12. All right. Only in A, 2, 7, and 9. G, -3, 0, and 17. Right. And remember, they're numbers from -3 to 18 integers. So -2, -1, 1, 3, 4, 6, 10, 11, 13, 14, 15, 16, and 18 should have been on the outside. Okay. Because they're not included in set F and set G. All right. So F and G. What would be in F and G? Abigail? 5. Good. 5, 8, and 12. That's the intersection. Then F or G or both. Yep, right. Good. Good. All right. Then what is not in F? Not in F. Yeah, Andrew. Yes. Good. Forgot you put them in order. So, not in F includes -3, 0, and 17, and all the numbers on the outside. When I post this, it will have it all listed, okay, for you to see. So, not in F is -3, 0, 17, and the outside. How about not in G? John? Perfect. So, not in G, 2, 7, 9, and everything on the outside. Good. Excellent. Then for E, what is not in F and G? So you're excluding the intersection. Mustafa? Mm-hmm. Perfect. Okay. So not in F and G. 2, 7, 9, -3, 0, and 17, and everything on the outside. Okay. And for the last one, what is in F? What is not in F, but it's in G? Sam? Perfect. Okay. How many of you guys did get that right? Awesome. All right. Your homework, which you can get started on now, is in your practice packet. 3.3 practice all. So I think it's just the front and back. Yep. You have it. I give it all last class. Okay.